As soon as you start trying to name ring systems, you're going to encounter situations where a new set of terms is going to be useful for the rings, and that is cis and trans. And this is highly related to what we were just doing with the double bonds. And cis again will mean same side, whereas trans will mean opposite side. And what I've drawn for you here is 4 different examples of cyclohexane rings that have various substituents on them. And then down below, I've drawn them in the way that you're more used to looking at them. So if you're looking down on each of these rings, then you would get the picture that I've drawn down here. But if you're looking at it at this level, this is the way we're going to eventually represent 6-membered rings more often than not, which is to say in their chair forms. That terminology will become much clearer later. But for now, just keep in mind that there are ways of representing structures that involve looking down on the molecule like this, and there are ways of representing structure that look sideways, sort of with a perspective view. But in any event, these are the same molecule. All I've done is represent the same molecule 2 different ways. So again, you're going to get used to flipping back and forth between these. But for now, what I want to do is illustrate that substituents that are on the same side of the ring, we would call those cis, and substituents that are on the opposite side of the ring, we would call those trans. And so this molecule over here is going to be a dimethyl cyclohexane, and it's going to be at the 1 and 2 positions. So this is arbitrary numbering because it doesn't necessarily matter when the priorities are the same, but that would be 1, 2, 3, 4, 5, 6 around the ring like so. And so I would call this a 1, 2 dimethyl cyclohexane. And now the only question becomes cis or trans, and so if the methyls are on the opposite sides of the ring, one is pointed up and one is pointed down, then this would end up being a trans 1, 2 dimethyl cyclohexane. And that would be a perfectly acceptable name at your current level of development. A little bit later on, you're going to want to do things like actually assign the stereochemistry of those so you can be explicit. If this is explicitly up and this is explicitly down, and so on. For this molecule, what we have now is going to be a 1, 2, 3, 4, 5, 6. So this will be a cis 1, 3 dimethyl cyclohexane. Again, what we have is 2 methyls, they're both on the same side, and they're at the 1 and 3 positions. So cis 1, 3 dimethyl cyclohexane. Here, now we have a different possible set of priorities. You could number this as 1, 2, 3, 4, 5 around the ring, or you could number this as 1, 2, 3, 4, 5, 6 around the ring that way. Here, what I would do is call this a methoxy versus a methyl, and so I would number this as 1, 2, 3, because again, you're trying to have the lowest possible numbers overall. So this is going to end up being a 1 methoxy 3 methyl cyclohexane. And what I'm going to have to do here is call this a cis 1 methoxy 3 methyl cyclohexane. Again, I was making that decision based on alphabetical, methoxy before methyl as the priorities, and then I was saying that you want to have the lowest possible numbers, which are 1, 3 rather than 1, 2, 3, 4, 5. So 1, 3 rather than 1, 5. Cis, again, because of the arrangement of these two, they're both on the same side of the ring. In this case, they're both down as drawn. Here, they were opposite, they were trans. Here, when they were cis, they were both up. Now we reach the molecule that cannot be described in these simple cis and trans terms, and that is entirely because this is a 3 tri-substituted cyclohexane. So this is going to be a fluorochlorobromo, and of course, for the purposes of alphabetical order, I would call this a bromo first, followed by chloro, followed by fluoro. And for numbering purposes, I'm going to call this 1, 2, 3. Again, we'd like to have the numbers as low as possible, and if you have the choice, the alphabetical one would be first. So 1 bromo, 2 chloro, 3 fluoro, cyclohexane. But we can no longer use cis and trans to refer to the arrangement of the molecule overall, because though the bromine is cis to the chlorine, and the bromine is trans to the fluorine, the chlorine is trans to the fluorine, the chlorine is cis to the bromine, and so on, we cannot define them over the entire molecule. So as you noticed, I can say that the chlorine and the bromine are cis to each other. I can say that the chlorine and the fluorine are trans to each other. But if I want to name this unambiguously, I'm absolutely going to have to assign R and S. But that's a topic for a later time.